Okie dokie. Yep, there we go. Okay, wait and drag. You can write that down. Oh, you're all in different colours today. You're not coordinated. Did you not phone each other this morning to decide what you're wearing? No? Oh, okay. Right, wait and drag. Ah, you could match off quite nicely then with your white shirt. Yeah. Right. Wait and drag. Okay. Does anybody know this word, gravitational force? Gravitational is an adjective. Does anyone know the noun? I'm sure some people. Gravity, yeah. So what's gravitational force? Well, that's a fancy word that tells us the force of attraction between all matter. Normally only felt when extremely large. So, obviously we have the earth and things are pulled to the earth. Or you have the sun and things are pulled to it. Yeah? Yeah? So gravitational force is the force of gravity. It's, there's the sun and there's earth and there's a force here. But what's interesting is this force is in every mass. So it doesn't matter. You have a mass, and this one is pulled here and then this one is pulled here. It's for every mass. But it's so weak. It's so weak. We can only feel it when it is very large, like Earth, Moon, Sun. So I know it seems strange, but this pen here, this is true. This pen is pulling all of you towards it because there is a gravity force. Okay, but it's so weak. Not possible to measure it. So weak, but technically true. There's a force pulling all of you towards this pen, towards this table, towards me. It's so weak though. We only feel it when it's really big, like the earth, and we're being pulled down to the earth. Okay. So this is called gravitational force. This is an important vocabulary item. It's the force that keeps you on earth and not floating in space. Yeah? Regina, you can see okay sitting there? You don't need to move? It's okay? Are you sure? Okay. Screw it, let's just move the tables. I'm so tired of looking at you sitting like this. I think rows would make most sense, wouldn't it? Anyways, my wife's in hospital. No one's going to say anything to me. Or are they going to say, oh, I can't don't move the tables? So I'm thinking, will we make 2 rows?
Yeah.
2 rows? Yeah. How about we push this one up a little bit? Like we can have it lined up at the wall there. Then we can put 3. And then how about we put 3 behind it? Huh? Yeah. Well, we'll leave it there for the moment. We'll just put this here. Yeah, we can put 2 more here.
2 rows of 6.
2 rows of 6, maybe? We'll leave a little gap in the middle. Yeah.
So this one, I have plenty of space here.
Where are we putting the gap? I suppose here in front of my desk, yeah.
You can take this one.
And we can put a tree behind it, no?
Yeah, so 2 rows of
Yeah, we don't need, this is an extra table, we'll just push it out of the way.
Put it down there for the computer and everything.
Yeah, well, we can, oh, maybe so, oh yeah, I see what you mean. Yeah.
There is a stand.
That's a good idea. Good stuff. Now, we have 2 tables spare, so what will we do?
Well, why don't you join one and the other one?
What do you mean?
Table in the middle.
But then it'd be, we kind of want this to walk.
Okay.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, who's in using this room? Is it just this group? Are you ever in this room with more than?
Not really, no.
It's just kind of usually these numbers.
Yeah.
Yeah, well then that should be okay. We'll just leave it like that then.
Oh, this is so much better.
Yeah. Yeah.
It's much better than
This is much better, huh? What class do you have after this one?
nothing lunch.
It's lunch.
And then?
And then
Academics.
academics is
In this room?
no.
Okay.
D2
Better?
So we have your wife to thank.
Yeah, do, yeah.
Please pass on that.
I'll pass that on, Alright, we got that, we continue? So, does anybody want to give me the definition of weight then?
The force
Yeah?
that the earth
Yes?
exerts on an
Yeah,
object on or near its
That's
surface.
it, the amount of gravitational force experienced by that object. Now actually you said by the earth, perhaps I should have put that in too, because it is the earth that causes it, but I guess because maybe I should have put in caused by the earth. Anyways,
That's how I
should really have that in.
on or near its
If you want to add that into the definition, like in brackets, by the earth,
Where would be?
you could say the weight of an object is the amount of gravitational force experienced by that object caused by the earth. You could just stick that at the end. Okay, you got that? I would like you to write at the end, caused by the earth. Yep. Okay. Can I continue? Yeah? Continue?
Yeah.
Okay. Let's find a formula for the weight. It's pretty straightforward. So, here's the earth. Here you are on it. And there's going to be a force pulling you down called W. This W is a force, but Newton said force is MA. And we actually know what the A is. What is it? Gravity G, isn't it? The 9.81, yeah. So I won't put in the minus because we'll remember that weight acts downwards. But you're right, it is a down force, so it's a negative. So this gives us our simple formula for weight. Weight is just mg. Yeah. Weight, W, M, mass, and G is the acceleration due to gravity, which we did recently. Yeah. Got that? Yeah, continue. Right. How much, now this is an easy one for you to do with your calculator. How much does a 2 kilogram physics book weigh on Earth? Yeah. 19.62 newtons, yeah. 19.6 newtons. Easy peasy. How much does a 2 kilogram physics book weigh on the moon? And assume the acceleration due to gravity on the moon is 6 times smaller than Earth. So the g on the moon is actually g over 6. It's 6 times smaller. So what's that going to be, about 4 newtons? 3.27 newtons. Okay, that's easy peasy, right? A 2 kilogram physics book weighs 4 newtons on an asteroid. What is its mass on the book? Sorry, I should just say what is its mass. Still 2 kilograms, yeah. Right, which will hit the ground first? Yeah, the bowling ball will hit the ground first.
Depends
But
of if
If it's in a vacuum,
Yeah,
you'll hit it at the
Yeah.
same time.
there's actually,
imagine you were dropping it in real life.
Oh yeah.
Yeah.
There's actually
Unless you have a vacuum at home you can step into, no?
No, there's actually a cool video.
I know, I saw that video. That was done by BBC, I think. Brian Cox video. Yeah, no, it was great.
Huge.
I remember. No, that was BBC. Brian Cox is the physicist. I saw that video. It was fantastic. This giant vacuum chamber used by NASA, I think.
Maybe,
Yeah,
yes.
probably NASA. Yeah, and he dropped the 2 of them. And what I found so strange about that video is the way the feathers hit the ground.
Yeah.
They looked so heavy because the bowling ball hits and it does what you expected. It goes bunk and then falls. But the feathers, they hit and they go bunk. And it looks, without the air, it looks like they're so heavy. Because with a feather you expect it to go and then just like this. But it hits and it bounces like the bowling ball does. If there's time, maybe we'll look on YouTube for that video. You're right, it's a very nice video. But in real life, not in a vacuum, the bowling ball will hit the ground first. Now you might say, well, what exactly is happening here? Because if they both, there's the feather, if they both have the U is the same and the A is the same and the T and the S is the same, let's just make it 1 meter. They both have the same U, A and S.
And then you have the resistance. And
Yeah, the problem is actually here that this one, the A is roughly minus G. But here the A, I would say, is actually, it's probably nearly 0. It's not really accelerating because it kind of goes down at a constant speed. And that's because we haven't considered a second force. So although we have the weight, there may be another force here. And what's that called? That's the drag, yeah, in the name of the lesson, weight and drag. So this is called drag, but you can call it other things too. Does anyone know another name? What is that drag? Resistance, air resistance, anything else? Friction, yeah. Resistive force, frictional force. There's many names for it. Drag is the easiest one. Okay, so when a force causes something to move forward, I usually call it a driving force or a forward force, but really the name for it is called a thrust. This is the force that makes it go the way you want it to go. The force which you don't want, that's slowing you down, this is called a drag force. Okay. I think it'd be nice if you could just draw a little picture like this with thrust and drag on it.
Shown below are two important forces. So gravity and the normal force are not considered important.
Not so much in this picture, because unless you're going up a hill,
Yeah.
the gravity is not such a big deal. Now, I'm not saying it has no effect.
Yeah.
I mean,
It has
you have to
an
consider
effect.
gravity when you're going up hills, when you're turning corners, if the road is icy, these things don't matter. But normally for a car, you mostly care about these two forces.
And the coefficient of friction between the tires and the road.
In fact, we don't study coefficient of friction in this course, so we don't actually do the formula for friction. I know the one you're talking about. Yeah.
Because in the
That
car you have a lot of
depends on that
Yeah.
flow of braking forces and your acceleration.
In real life, the formula is much more complicated because it'll depend on the shape of the car,
Yeah,
aerodynamics and
aerodynamics. It depends very much on the speed of the car. What happens to the drag force if the car was going faster?
increases.
It increases.
Yeah.
Yeah. The only time the drag force is zero is when the car is at rest. Then as the car moves faster, the drag force increases. Yeah? Yeah.
Does the drag is the same in an electric car like a combustion engine in a car? Or?
For the electric cars,
Depends on
they
the
tend,
shape.
yeah, it depends on the shape. My experience is with the electric cars, they try to make it more aerodynamic than a regular car to help increase the battery,
And the range.
the range, yeah. Because in a normal car, you can afford to waste some energy on the shape because it's easy to fill up. You can fill up anywhere. But in an electric car, when it's difficult to have a long range, you want to squeeze every efficiency that you can. That's the problem why my car broke. My car's a hybrid, and the electric part broke. The hybrid battery.
Which is hard to replace.
More importantly, it's expensive to replace.
Wait, I got a question.
You know, €3,000 for a new hybrid battery.
Wow.
So I think I'll try to buy a used one. But of course, the problem with the used one is I know it won't last as long.
Yeah.
Because you all know this from your phone and your laptop.
Yeah. Only
We'll actually talk about this when we do electricity. But batteries, they only last so long, and then what happens to them?
They lose it.
You can't charge them anymore, right? So like your battery in your phone, how long will that last before it breaks?
It also depends on how
Depends if you use it.
Yeah. So all of you would be heavy phone users. So how long would your phone battery last? 2 years sounds about right. Yeah.
It depends if you have
Maybe
an
it
Apple.
depends on your phone
If
too.
it's Apple, they make it last 1 year. So you
I would
Yeah.
believe that.
So
I
I
would
have
believe
it with
that.
my phone
And
for 2 years.
and you can't easily replace it,
Yeah.
Yeah, no.
right?
So they force you
Yeah.
to upgrade.
They force you to upgrade. What about a laptop battery? That's about the same, isn't it? 2
Yeah,
years?
2 years.
3 years? Yeah.
2 to 3 years.
So I can tell you that a hybrid car battery will last you about 100,000 kilometres or 7 years, which isn't really that good if you think about it, because for a normal car you should have no major problems for at least 200,000, and then maybe you might have to replace the transmission or something like this. So I'm not so a fan of hybrids anymore. Not when you get a big bill coming your way,
Is it a Prius?
A Civic, Honda Civic, yeah.
It was a Prius. I watched this guy he did a DIY tutorial
On how to change it.
Yeah.
I wouldn't try. I'd electrocute myself if I tried to do
Yeah,
that.
but it's actually high voltage.
It's very high voltage, yeah. They don't want you messing with that, no. Does anybody know this word, terminal velocity?
Yeah.
What's it mean?
It's when the drag equals the
Exactly, yeah. In this picture here, what will happen is the car will keep moving faster and faster. Then the drag will increase and increase and increase until the drag equals the thrust. what is happening to the car at that point?
Doesn't accelerate.
Doesn't accelerate. Very good. It's moving at a constant speed. This speed is called terminal velocity. Terminal velocity is the maximum velocity. Now, please note, we usually use the expression terminal velocity when we're talking about something that's falling. Free falling, yeah. So what happens is it falls, gets faster, the drag increases, and then it will equal the weight, and then it just moves at a constant speed. So an object like a feather will reach its terminal velocity quickly because it has a lot of drag. An animal like a cat will reach a terminal velocity pretty quickly. Not that I recommend you do it, but there are situations where a cat has survived being thrown out, 20, 30 metre building.
Sure.
Yeah, because as the cat falls, it spreads out,
Yeah.
tries to increase its drag. And then at the last moment, it will crouch in and fall, and it will try to bend its legs as much as possible. Now, if the cat falls from a very high distance, it can be okay. A small distance, it can be okay, but a medium distance can be hurt, because if the cat is in between, if it's not high enough to reach its terminal velocity, or if it doesn't have enough time to get its legs ready when it hits the ground, this is actually where the problem is. So, if it's funny, because if you threw a cat out this window, I don't think it'd be okay. But maybe if you threw it out a floor higher, it might be okay. We won't test it. We won't test it. Okay, so the famous example is with the parachuter. So, as he falls, his weight increases until it equals the air resistance, the drag force. Then what happens is he opens the parachute. The parachute has more drag, and it will slow him down until the drag then equals the weight again. But even if he didn't open his parachute, he stops accelerating. But still a problem, because he's still going quite fast, even though he's not accelerating. And this, we talked about this earlier, drag force is often proportional to a speed term, which is actually quite difficult. So what you're saying is, as he's going faster, the force increases. It's a little bit too difficult for us to fully factor that into the calculation. Okay. Here's actually, we don't do that, we've talked about it already, and I know we won't bother with that one. But here's a tricky one. A 100-gram steel ball is dropped in a tall beaker of oil. The oil is 80 centimetres deep. Calculate the drag force, and it takes 10 seconds. So, roughly, what would you think? Imagine that this is 80 centimetres, and this is 100 grams, and this is open. It falls freely. What type of time are we talking about for this to hit the bottom? I don't know, a second, maybe. Less, maybe. It just, bump, down it goes. Okay? 1 second, maybe, something like that. But if I fill this up with oil, it will take a longer time to hit the bottom because of the drag. Okay? Let's say, in fact, with the oil, it will take a time of, what did I say? 10 seconds. So it's going do quite slowly through the oil, hits the bottom. I think you could do this. What I want you to do is to calculate the drag force. Okay? 100 grams is a nice number. What does that make the weight equal to? What is it, 100 grams? It is 0.981 newtons. So that's an easy calculation. Right, I'll give you 1 or 2 minutes. See if you can give me the drag force. I'll draw the picture here for you. It's got two forces. Now, before you start, technically speaking, what's the drag force when it's just about in the oil? It's 0, because it hasn't really moved through the oil yet. As it falls through the oil and gets faster, what's happening to the drag? It's increasing. And when is it maximum? At the bottom. So for these questions, what you often do is you assume the drag is constant. So you pretend that the drag force is a constant force. Now it's not really constant, because at the beginning it's 0, and at the end it's quite big. But just assume it's constant for the question. See what you can come up with. You'll need to use F equals ma for sure. And you'll need to calculate A. How are we doing? Yeah, you got it? Yeah? Let's have a look. It should be enough time. So look, I want to calculate the A first. That's what I want to do first. So we know the U, it's 0. We know the, well, we don't know the V. We don't know the A. We do know the T though, and we do know the S. Technically minus 0.8. Although if you wrote plus, you can fix the signs later. It's fine. Did you all get A? What's the A? 0.016 meters per second squared. Yeah? Okay, now, here is the ball bearing. What is the force on this? It's down, it's negative. F equals ma. 0.1 times minus 0.016. That is minus 0.0016 newtons. Is that the drag? No. That F is the total force. It is what you get when you combine the weight with the drag. It's the resultant. In other words, the weight, which we said is 0.981 down, minus the drag up, should equal 0.0016 down. So we can get the D from this formula. So what's the D if you were to do this? It should be still pretty big. 0.98. 979? 979 newtons is the answer.
Upwards.
Correct, upwards. Okie dokie? Yeah. Did you get that? Good job.
I forgot to change the 80 centimeters to meters.
Oh, man. Amateur mistake.
Yeah.
All right, continue. So, I have another hard question here, but to be perfectly honest, it's probably too hard for the exam. But if anybody wanted to try a hard question, you could watch this video later tonight and have a look at this one. Okay? Well, you know, it's not too bad. And I don't know why I wrote 20C instead of 20 seconds. That's that should be seconds. I don't know why I did that. Anyways, what we'll do, for about 5 minutes only, just try a couple of the homework questions and then we'll start the next topic. How many questions are there for this topic?
4.
Just the 4, yeah? So it'd be great if you got at least one of them done and then we can start the next lesson, okay? Can you try them now?